been doing, going through the motions of finding out, especially static concepts versus dynamic concepts, and whether Father Universe, all the atoms in the universe, whether they belong to the first set or the second set. Okay? And so we begin with what I call the golden principle of physics, okay? Foundations of physics. Okay, what are they? The golden principle is physics requires an object. You can't do physics without an object. If we erase all objects in the universe, there's nothing there, nothing is happening. What are you seeing? What are you imagining? What are you visualizing? What experiment can you run if experiments are part of science? I mean, nothing's happening because there's nothing there. So the first thing you need in physics is an object. You can't do physics without an object, like the mathematicians do. They do action at a distance, which is the scientific version of black magic, of witchcraft. It's voodoo physics. They say action at a distance, meaning there's no mediator. So they're doing physics without mediators. It's even worse. They use concepts. They say it was the energy, it was mass, it was the field, it was the wave. No, those are concepts. You can't substitute an object with a concept, mathematical concept, and say, I explained it. And that's what they're doing. They're giving you physical interpretations using abstract mathematical concepts. Okay, so the first word you need to define in physics is the word object, because physics requires an object. You can't do physics without an object. Okay, so we talked about that a couple weeks ago. Okay, let's move on then. What's next? Next one is the word space. If you define what something is, you have to define what nothing is as well, because we have all these somethings and nothing out there. Okay, that's the universe. The universe is made of objects, the things, and it's made of nothing, which is the other half. We can call it not really a half, a little more than half, but we're talking about this contrast between objects and nothing. Okay, and so I like to put it this way. So something, objects, is a synonym of nothing, okay? An antonym of nothing. Something and nothing are antonyms, okay? And so only then can you make sense of these two words. What something is, what nothing is. Something, that which has shape. Nothing, that which doesn't. Very, very straightforward, okay? Is space infinite? No. Infinite is an adjective. It can only be used with objects with the somethings. You can say chair is green. You can say, that the rock is big. But you can't say that love is big. Not in physics. Okay? You can't use adjectives to qualify concepts in physics. And when you say that space is infinite, you're using infinite, an adjective, to qualify a concept. Nothing. No, nothing is not infinite or finite. Okay, so you can't say space is infinite or universe is infinite, because universe is also a concept. There's no thing called universe. Matter is the thing part of universe, and space is the nothing part of universe. Okay, universe is matter and space. Okay, so both universe and space are concepts. You cannot say the universe is infinite or space is infinite. Those are irrational statements, because you are using an adjective to qualify a concept. That's irrational in science. It's irrational in physics. Okay, and so, we have, here we have, again, my straw. I think it's better than the pens. I keep breaking all these pens, right, that when I do this. You let go of the straw, and it falls downwards, right? And so people say, well, there's nothing here and there's nothing there, so it's action at a distance. Somehow, apparently the Earth is attracting by some magical means the straw downwards. Okay? Now, there's no magical mean. Here we'll have good old Richard Muller, professor at Berkeley, and says if you have the Earth, there's a big mass here, and you have you with your little mass here. Every atom on the Earth is pulling on every atom of you. You're also pulling on it. Let's repeat that, because maybe a lot of people didn't hear it. Every atom on Earth is pulling on every atom of you. You're also pulling on it. How do you pull if you don't have a mediator? What are you going to pull with? Are you going to throw stones, discrete stones, at the thing that you're pulling? Are you going to do it with field, with energy, with mass? Are you going to do it with concepts? It says you're pulling on atoms right now on the other side of the earth. Okay? So yeah, the only way you can imagine pull is if you have an object, if you have a thing. So there's got to be something that we can't see here, something that we can't see here, whether pushing or pulling, right? That is attracting this to the earth. Why doesn't it go to the moon? Why doesn't it go to Jupiter? Why doesn't it go into outer space? Something obviously is pulling on this, okay? Some people say it's pushed, but everybody really defines or has this notion that gravity is a pull force. And Muller's telling you it's every atom on Earth is pulling on every atom of you, on every atom of the scroll. So you got to think about that for a moment, because apparently there's something that's pulling that we cannot see or touch. And yes, an object is not that which you can see or touch. What was it? An object is that which has shape. Not all objects, not all shapes, right, can be seen or touched. Among them, the air. In fact, here we have, for those of you who need authority to change your minds, here we have Brian Greene. He's going to tell it to you in your face, okay, so that you understand it well. Okay, here it is. Listen to him carefully.
We are surrounded, right, by physical substances that we know to be real, right, but which to the naked eye are invisible, right? Air, of course, but, yet more elusive examples are X-rays and radio waves and infrared rays. These are elements of the electromagnetic spectrum that are outside the sensitivity of our eyes. Of course, since, I guess it was around 2015, we have learned that we are also immersed in a sea of incredibly weak gravitational waves. So here's the thing. When we look out into the cosmos, we should perhaps anticipate that at least some of what's there might also be invisible, not just to the naked eye, but perhaps also to our most refined equipment.
Okay, so yeah, there are things that we cannot see or touch, and they form these objects, these things that bind any two atoms. Okay, and so what we propose is, on this side at least, is this. We have the electromagnetic wave, which is a concept, a mathematical concept, bunch of vectors. Okay, magnitude and direction. That's what they say these fields are. Field is just a bunch of numbers, value at each point in space. None of those are physical objects. Those are all concepts, and we're replacing that concept that came up with people like Augustin Fresnel and James Maxwell, and we're replacing it with a rope. They've been mistaking a rope for a wave, a transverse wave. Okay, rope is a physical object. A thread, it's made up of two threads. A thread is a physical object. A field is not. Field is a concept, okay? And whereas the electromagnetic wave goes one way and off to nowhere, the rope binds any two atoms, like Richard Muller said, pulls on one atom, pulls on another. Now you have a physical entity that can pull on another atom, okay? So now we are in line with what he said. And while it pulls, it also torques. And by torquing, you have light and gravity in a single mechanism, in a single cause, right? Single object. We have the theory of everything right there in front of me. And here you have this in motion. You have the quantum mechanics version, which is that ridiculous atom that cannot explain why the bead does not fall towards the center, you have the negative bead, and it doesn't fall to the positive nucleus, in this case the proton, right? And when it falls and rises, somehow it emits this abstraction, which is a gravitational wave, right? Whatever that is, it goes off to nowhere. And that contrasts with our model, which is two atoms bound by a rope, a pair of twine threads, And as it expands and contracts, you can see why it torques the rope. The torsion along the rope is what we call light, and the expansion and contraction is what we call the quantum jump. That's why, the little bead goes from one energy level to another. It's pumping back and forth. They're talking about a membrane, which they confuse for this bead that's jumping between energy levels or orbitals or whatever they want to call them, okay, which are all concepts. Here we have objects, okay? And so there's the difference between two models. In the case of gravity, because the same model explains gravity, here you have the version that they have, which is two black holes, and because they move around each other, they create these gravitational waves in what they call space-time. That space-time, the lines that you see there, those are number lines. That's what they are. It's not a fishnet. Okay, it's not a canvas like they illustrate there. No, they're talking about number lines. So they're not physical entities. They're mathematical concepts which they're turning into physical objects, bending them, running waves through them, which is all irrational because they're talking about mathematical concepts again. And then they have these two black holes, which are zero-dimensional, according to their definition. They have singularities at their centers and surrounded by concepts known as the event horizons. And so all you see there are a bunch of concepts which they've illustrated. They've illustrated the black hole, which is a concept, and they create gravitational waves, which are concepts, along a space-time, which is also a concept. All just number lines. And so that's their version, and we have a rational version because we're saying every atom is connected to all others. Every atom of the astronaut is connected to every atom on Earth, and therefore as he falls, the ropes that interconnect every one of these atoms fan out. And by fanning out, you have more and more ropes tugging on a separate axis. They have different angles now. They were superimposed before, now they're not superimposed anymore. And so because of that, you see the acceleration of gravity. That's what gravity is. So we have a physical interpretation, we have a rational version of it, whereas mathematical physics does not. Do you believe in the rope model? Do you believe that that's how gravity works? Do you believe that that's like how light works? We don't care. Science doesn't care. Science doesn't care if you believe or not. Belief is part of religion. We explain so that you understand. If you understood, we finished with science. What continues now is religion, belief, whether you're convinced or not. That's something else.